In mathematics, a binary relation R over a set X is transitive if whenever an element A is related to an element B, and B is in turn related to an element C, then A is also related to C. Transitivity is a key property of both partial order relations and equivalence relations. Formal definition. In terms of set theory, the transitive relation can be defined as examples. For example, is greater than, is at least as great as, and is equal to, are transitive relations. Whenever A greater than B and B greater than C, then also A greater than C. Whenever A B and B C, then also A C. Whenever A equals B and B equals C, then also A equals C. On the other hand, is the mother of is not a transitive relation, because if Alice is the mother of Brenda, and Brenda is the mother of Claire, then Alice is not the mother of Claire. What is more, it is anti-transitive. Alice can never be the mother of Claire. Then again, in biology we often need to consider motherhood over an arbitrary number of generations. The relation is a matrilinear ancestor of. This is a transitive relation. More precisely, it is the transitive closure of the relation, is the mother of. More examples of transitive relations. Is a subset of. Divides. Implies. Properties. Closure properties. The converse of a transitive relation is always transitive, e.g., knowing that is a subset of is transitive and is a superset of is its converse, we can conclude that the latter is transitive as well. The intersection of two transitive relations is always transitive. Knowing that was born before and has the same first name as a transitive, we can conclude that was born before and also has the same first name as is also transitive. The union of two transitive relations is not always transitive. For instance, was born before or has the same first name as is not generally a transitive relation. The complement of a transitive relation is not always transitive. For instance, while equal to is transitive, not equal to is only transitive on sets with at most one element. Other properties. A transitive relation is asymmetric if and only if it is a reflexive. Properties that require transitivity preorder a reflexive transitive relation. Partial order, an antisymmetric preorder. Total preorder, a total preorder. Equivalence relation, a symmetric preorder. Strict weak ordering, a strict partial order in which incomparability is an equivalence relation. Total ordering, a total, antisymmetric transitive relation. Counting transitive relations. No general formula that counts the number of transitive relations on a finite set is known. However, there is a formula for finding the number of relations that are simultaneously reflexive, symmetric, and transitive. In other words, equivalence relations, those that are symmetric and transitive, those that are symmetric, transitive, and antisymmetric, and those that are total, transitive, and antisymmetric. Pfeiffer has made some progress in this direction, expressing relations with combinations of these properties in terms of each other, but still calculating any one is difficult. See also